So this is the 2015 Lch Cert Higher Level Paper 2 and we're looking at question number 1. An experiment consists of throwing two fair standard six-sided dice and noting the sum of the two numbers thrown. If the sum is 9 or greater, it is recorded as a win. If the sum is 8 or less, it is recorded as a loss. Part A says complete the table below to show all possible outcomes of the experiment. So we've two spaces filled in already. This is a loss here because 2 on die 2 and a 1 on die 1. If we add those together, that gives us 3. The sum of the two numbers is 3, so that's a loss because 3 is 8 or less. So 1 and 1 would be a loss, 3 and 1, 4 and 1, 5 and 1, 6 and 1 would also be a loss, 6 and 2 would be 8, so that would be a loss, and everything below that as well. Then going down the side, these would all be losses. 4 and 1, 5 and 1, 6 and 1 giving 7, 6 and 2, again a loss. 3 and 3 is 6, that's a loss. 3 and 4 is 7, a loss. 5 and 3 is 8, that's a loss. 6 and 3 would be 9, so that would be a win. A loss for 3 and 4. Again, 5 and 3 would be a loss. 4 and 4 would be a loss. And now everything else is going to be a win. So all these spaces here give a total of more than 8. So that's our sample space filled in, our table. Part B1 says find the probability of a win on one throw of the two dice. So a win, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10 possible ways to get a win, and that's out of a total of 6 by 6 out of 36. So the probability of a win on one throw of the two dice is 10 possible wins out of a total of 36 outcomes. So 10 over 36. And that simplifies on the calculator in your head as 5 over 18. So that's B part 1. Part 2 says find the probability that each of 3 successive throws of the two dice results in a loss. Give your answer correct to 4 decimal places. Well, if the probability of winning is 5 over 18, well, the probability of losing would be 1 minus that. So 1 minus 5 over 18 gives us 13 over 18. So that's the probability of a loss. This was the probability of a win. Okay, so the probability of loss is 13 over 18, but we want to know what's the probability that each of 3 successive throws of the two dice results in a loss. So in other words, we're looking for the probability of a loss, followed by a loss, followed by a loss. That's 3 successive losses. So that's going to be 13 over 18 by itself 3 times, because the events are independent. One has no effect on the other. So that's 13 over 18 to the power of 3, in other words. And on the calculator, that gives us an answer of 0.3767, and on it goes. Well, we're asked to give our answer correct to 4 decimal places. So we're going to look at the 5th digit after the decimal. Does this 1 affect the 7 in front? The answer is no. So the probability is 0.3767. And that's the answer to B, part 2. Part C says the experiment is repeated until a total of 3 wins occur. Find the probability that the 3rd win occurs on the 10th throw of the 2 dice. Give your answer correct to 4 decimal places. Okay, so we need to think about this then in 2 stages. The first stage, well, the last stage, the probability that the 3rd win occurs on the 10th throw, well, that's just going to be the probability of a win. So the 10th throw, the probability of a win is 5/18, which we had from part A. The first 9 throws then, the first 9 throws, there is going to be 2 wins somewhere in those first 9 throws. So 2 wins somewhere, and that's what we need to work out. So what is the probability of getting 2 wins in a total of 9 throws? Well, to do this, we're going to use the binomial distribution. This is from your tables book. And to use the binomial distribution, we have to identify n, which is the number of trials, r, which is the number of successes as you define them, p, which is the probability of success as you define it, and q is the probability of failure. So there's 4 letters, n, or, p, and q, to be able to use the binomial distribution. So for the first 9 throws, the number of trials n will be 9. The number of successes, or, is going to be 2, because we're wondering what's the probability of getting 2 wins. So we're going to define win as a success. So that's or. Our p-value, the probability of success, is the probability of a win. That's what we're looking at. So that's 5/18. And q, then, the probability of failure will be 1 minus that. So 13/18, as we've already worked out as well, the probability of a loss, or a failure as we define it. So now what we're going to do is plug these numbers into the binomial distribution. So that's going to give us NCR, which is 9C2, multiplied by P, which is 5/18. These are all multiplied, these things. NCR times P to the power of R times Q to the power of N minus R. So it's 5/18, the probability of success, by the number of successes, 2, multiplied by the probability of failure to the power of N minus R. Now N minus R is 9 minus 2, in other words 7. But we can just plug the values in there, 9 minus 2. And then we're going to put all of this then here into our calculator and work it out. So in your calculator, this 9C2, or 9 over the 2 here in this bracket, the other way you can write that is in your calculator is 9C2 like this, using the NCR button on your calculator. So it's going to be this that you enter into your calculator. But before we enter this into our calculator, we have to remember to multiply this by the last throw, the probability of a win on the 10th throw. So the answer then to the question is actually the 9C2 times 5/18 to the power 2. In other words, all of this multiplied by this. Multiplied by the 5/18. So all of this then into the calculator will give you an answer of 0.07908 and on it goes on your calculator. But we were asked to give our answer correct to 4 decimal places, so I'm going to look to the 5th digit after the decimal, which is the 8, and ask myself, does this 8 affect the 0 in front? The answer is it does. So my answer then will be 0.0791, the 8 knocking the 0 up to a 1. So that's my probability correct to 4 decimal places, and that's the end of question 1.